This video will walk you through a simplified example first, then a slightly more complex one, and finally the version that replicates the borders pieces. We first start with a set of points shown here in red. In this case, they form an octagon. We identify the midpoint between two consecutive pairs of points. We could add some noise to the midpoint, but in this case we will keep it simple. We will add noise in the next example. We use the midpoint as the control point and draw a Bezier curve that connects the two endpoints. We sample 3 points along this curve as shown here in red. Repeating this for all pairs of points, all pairs of consecutive points, gives us a new set of red points. The black cross is the centroid of all points. We now loop through all consecutive points again and pick a midpoint, shown in blue. We move away from the midpoint in a direction orthogonal to the line formed by the two endpoints by a predefined amount. And we pick the point that is away from the centroid, that is away from the black cross. We repeat this for all consecutive pairs of points. We will now go back and alternatively connect a red point to a blue point and the blue point back to the next red point via quadratic Bezier curves. Let's start with the first red point and add some noise to it. We then pick the blue point right after it and add some noise to it. The green point is the midpoint of the two noisy black points, and we added some noise to this green midpoint. We draw a quadratic Bezier curve connecting the noisy endpoints using the noisy midpoint as a control point. We repeat this to connect the same blue point back to the next red point. And we keep repeating this till all consecutive red and blue points have been connected. This gives us the initial shape. We will now scan through all columns and fill each column from the lowest to the highest point in the shape. And we will now do the same thing horizontally to fill each row from left to right. So now we have the vertically filled version and the horizontally filled version. We combine the two and we dilate the resultant blob. And we keep the diff between the original blob and the dilated blob. This gives us a version, an initial version, a simplified version of borders. We will now repeat this process, except this time we will add some noise to the very first set of midpoints that we compute. Everything else remains the same. So this gives us the second version of the borders pattern. And now we'll see the final version. In this final version, we'll repeat the same process, except the initial set of points form a square instead of an octagon, and the amount of noise we add to the initial set of midpoints is much larger. This larger amount of noise makes it harder to keep track of the process by looking at it visually, but algorithmically, the process is identical to the two examples we've seen so far. So let's see what this last example looks like, which will give us the final version of the borders piece.